In this video, I'll be showing you how to create and recognize probability distributions. First, let's start with the definition of a random variable. A random variable is the outcome of an experiment. So in this case, we'll be looking at probability experiments, and the random variable can be any of the possible outcomes in the sample space. We use X, a capital letter X, to represent the random variable. And once again, since the values that X can assume are going to depend on the experiment, X is not always the same thing, and X cannot assume any different variable. It's going to really just depend on what the experiment is. So let's start with what a probability distribution is. So the format will be a table with 2 rows, and it displays the probabilities of all outcomes in the sample space. The first row will display the different values for the random variable X, and then the second row will display the corresponding probability for each random variable. Here's an example. Our experiment here is a bag that contains different marbles with different colors. We have 5 red, 3 yellow, 6 blue, and 4 green, and we're going to select 1 marble at random. So once again, X is going to represent the color of the marble. So our probability distribution would look like the following table that you see at the bottom of your screen. So the first row, you have an X, and that can represent the different colors, red, yellow, blue, or green. And then corresponding to each of those values, we have the probability. So the probability of X when X is red is 5 out of 18, for yellow is 3 out of 18, for blue is 6 out of 18, and for green is 4 out of 18. And once again, the 18 came from the fact that when you total up the number of marbles in the bag, you have 18, and for each different color, the numerator is just how many there are. So once again, notice that we just list the different outcomes in the first row, and then the probabilities of those outcomes in the second row. Now, some characteristics of a probability distribution are, first, the sum of all probabilities is equal to 1, and that's just because the distribution displays the probabilities for all of the possible outcomes. So when you add them all together, you should get the probability of 1, because those are the only things that can happen for that experiment. And then, of course, just from your definition of probability, all probabilities should be between 0 and 1. It can be 0 if that particular event is certain, and it can be 1 if that particular event, excuse me, I should go back 1 second. It can be 0 if the particular event is impossible, and 1 if that particular event is certain. And that's just, again, your regular definition for probability. Now, you shouldn't be fooled. Just because something looks like a table of probabilities does not mean it's a probability distribution. And of course, what you're going to check is that your probabilities satisfy the definitions. So the sum of your probabilities should be equal to 1, and none of your probabilities should be negative or larger than 1. And that goes for if your probabilities are represented as fractions or as decimals or as percents. So in this first example, we have a random variable X can assume the values 1, 2, 3, or 4, and then the probabilities are given underneath. Now, these probabilities all look okay. They're all positives, and they're all between 0 and 1. However, if you add up these probabilities, you'll see that the sum is larger than 1. And this is easily seen here. You have fractions, all of the denominators are 10, but if you add the numerators, 4 plus 1 plus 8 plus 2, that's going to give you 15 out of 10, which is larger than 1. So this would not be a probability distribution. For the second example, your random variable, X, can assume the days of the week, Monday through Friday, and you're given some probabilities below. Now, right away, Tuesday's probability should stick out at you because that is not really a correct way to represent a probability. Probability cannot be negative. So right away, this is not a probability distribution because this is not a true probability. Even though if you did add up these decimals, you will see that they add up to 1. That does not matter because this is not a proper probability. Okay, so once you have a probability distribution that's set up correctly, you can go ahead and graph that distribution. Now, the characteristics of the graph are the following. The random variables are displayed along the horizontal axis, and once again, always space them evenly. This is the only time where you're not going to think of that horizontal axis as a number line. You're just going to list them out, evenly space them, whether they're qualitative data or quantitative data. Now the probabilities are displayed along the vertical axis. And of course, as always, use an appropriate scale. And because these are all probabilities, 1 should really be the highest value because the probability cannot be more than 1. And here we use vertical lines that are drawn at each random variable. And the height of the line is determined by that probability. So let's take a look at our example from before. So here we have the same probability distribution with the marbles being drawn from the bag, and below you'll see the graph of that probability distribution. So notice along the x-axis or the horizontal axis, we've just listed the random variables. In this case, they are colors. Notice that they're evenly spaced, so here they're all 3 spaces apart, and always leave a space before the first one. It should never be on the vertical axis. Now notice the scale along the vertical axis. The highest value is 1. That would be 18 out of 18. And I'm using values out of 18 because that's how my probabilities were given in fraction form. But of course you can certainly rewrite your scale in decimal form or in percent form, however your probability distribution is given to you. So here every 2 units on the grid is equal to 3/18, so the numerators all go up by 3, but the denominators are staying the same. This top one, 1, could be represented as 18 out of 18. Now for each random variable, there's just a vertical line, I sometimes call them sticks, that are drawn at each one. So for red, the height is approximately 5/18 because that's the probability. For yellow, the height is 3/18. For blue, the height is 6/18, and for green, the height is about 4/18. Okay, so this concludes our mini lesson on probability distributions. You will be talking about some examples in class, and you'll see that most of the time you're just going to want to understand how to construct a probability distribution given an experiment. You'll need to evaluate whether something is actually a probability distribution, and that's just by looking at the sum of the probabilities, checking that they're equal to 1, but also checking that all the probabilities make sense, so no negatives or no values that are greater than 1. And finally, you'll be asked to construct a graph, and it'll just be like the example that you've seen before, where you're just putting your random variables along the x-axis, your probabilities along the y, and just drawing those vertical lines that correspond to each probability's height. So that concludes our lesson for today, and we'll talk about this in more detail in class.